come from spring break, you have tests. So I don't want to think about it.
No, right?
Oh.
Computer architecture. We have it next week, and then when you come back from break. Second.
Okay. Let me create March 15th, right? Here.
But yours is
The next Monday at this class is Persian New Year, so I spend it in the class.
What, Nauruz?
What?
Nauruz?
Yes, no. Okay. In the site, celebrate now. It's at this class.
21st?
Okay. So let's play a little bit. We have talked about creating classes, right? And about arrays. So let's go over them again. I'm creating a new package. So let's create a class for a product. What does a product have? What does a product have if you're selling stuff? That would be good to have, right? Let's say that we have a name, right? Which would be a string and a price, right? This is kind of the simplest possible way we could do things. In our main, we could have our standard public static void main. In here, we could create a product. And then we can do stuff like this, p.name equals p1, p.price equals 1.1 bucks. Right? This makes sense? This officially sort of breaks encapsulation, right? Because this guy is just keeping the data. But it's reasonably okay, right? We could have a constructor, right? What's a constructor? Looks like a method, doesn't have a return type, has the same name as the class, right? And it serves to initialize instances, and if you don't define any, you get a constructor with no parameters that does nothing. If you define your own, then they can only create new instances using the constructor, right? So we could create a constructor, same name as the class, no return type, string name, price, this.name equals name, this.price equals price, right? Try to run this, it shouldn't compile. Yeah, because now I have a constructor and I don't have this constructor, right? I could do it like this, or I could define a constructor with the right parameters, right?
Or you can delete that.
If I delete the other one, yes, by default, Java defines, if you don't define any constructors, it defines one that takes no parameters. and basically calls the noargs constructor on all of the members. Hey, well, on the primitives. It'll do other stuff depending on inheritance and things like that. So we could have this. Right? What happens if I print P1? It's going to print something horrible. The class, right? And then a horrible number, right? You are not supposed to know what it is, right? But you would notice that when I print P2, I'm going to get a different horrible number. Right? Sorry? Well, what is happening if you go deeper, right? It's printing the identity of the object. In reality, it's printing the address, right? In memory of that object. Does that idea make sense? You will see this in computer architecture, right? The memory is one big array of bytes, and so this is printing kind of the address at which the first byte that corresponds to that object is stored. Probably. There is no guarantee that that's what it does, but yeah, that's what it does.
So those 8 characters are 1 byte, the first byte, of the product?
This has the first byte, that has the first byte of that P1 product, right? And then the other one has the first byte of that P2 product somewhere. And these are hexadecimal numbers. A hash code is something else. We will see more about hash codes later. Hash code is a way to cheat for storing data. But yeah, no, it's not that.
Do we have to make a new method to get the...
Yes. What's the name of that method?
Get?
To get what? Well, what's the name of the method that gets called when you print this guy, right?
We can't do toString?
It's toString,
Yeah,
right?
toString, right?
So we need to define public string So if we were to now run this guy, we get more useful information, right? Chances are that you want to define your toString.
We can do toString without.
You can. This is a piece of magic that we haven't talked about. Every object in Java inherits from a class called object with a capital O. That class called object, we haven't talked about inheritance, we will in a week or two. That class called object defines a toString method that prints the horrible thing that we had before. So you could just call it directly, even if you haven't defined, because it is defined. You are getting it through inheritance.
Yeah, for programmers, you don't need to use this method, right? Because they understand hex. But this is for the normal user?
Yeah, well, this is for you, actually. You don't understand hex. you don't know where the heck is this in memory, right? If you want to print something, you don't want to print the address, you want to print which product you're doing. If you're debugging or something like that, right? This is more what you want to do. It's probably not right for the user, because the end user, you may have different ways of presenting the information. So this is more for programmers. You never want to see the address of your object, unless you're doing assembly or C++ and you need to know the actual address. But normally you don't. To have the compiler do more stuff for you in Java, and this is something that you don't do in other languages. You can mark your method, annotate your method with @override, and that says, I think that I'm overriding the method for my superclass. If that's not true, then tell me, right? So if I mark it, right now it would work, because we are overriding that method, right? If I mark it and it's not true, let's say that I do int dummy, right? And instead that I override it, when I try to run this thing, it's gonna complain. You told me that you're overriding and you're not, so let me yell at you. We could just not mark it, and then what happens? On both of these cases, we'll be printing the same old stuff, right? Because now this toString method takes an extra parameter. If we delete it, then life will be good. You don't need the @override, but it's kind of an extra safety thing. Does this make sense? We have methods. Override just says, hey compiler, I think that this method is coming from my superclass. If it's not, please yell at me. So it will yell at you. Does that idea make sense? It's just an extra thing for the compiler to check. If you leave it out, it's perfectly okay. If you leave it out, you're increasing the chances that you mistype the name or something like that, right? If I don't leave it like this, then if I do this, and I think that I'm overriding the one from the object, what's going to happen? What's going to happen if I run this? I get the ugly stuff. I get the old method, because I didn't override the one that I thought. So, as an extra safety, you may want to do this. Does that idea make sense? And again, keep in mind here when I'm doing name, I'm saying the name of the object on which this method got called, right? So you always have this being passed unless you're a static. So this is cool. You understand objects. We have methods. We can create methods that do things, right? We could create getters and setters. I probably asked you to do it in the assignment. I don't do it here because I want to save time, because I want to cover more stuff rather than defining stuff that you will get to define 700 times. Now let's talk about arrays. An array is a bunch of things of the same type. When I declare it, I use the square brackets. And then I can do this. I can initialize the array with the braces. And then I can have a for loop. and then I can use the square brackets to get a given element in an array, right? This is cool. This is one way of doing this. Another way is with the for each loop. Where instead of iterating over numbers, right, from 0 till the last of the array, I'm iterating directly over the elements.
Why prints name equals P1 or name equals P2? You never call the toString method.
Java does magic. That's one of the few pieces of magic. When you need to convert and cast an object or convert an object into a string, it automatically calls the toString method. Does that idea make sense? In fact, let's see. Maybe I can even do this. Let's see if it works in general situations. It's just... No, it doesn't let me do that. So it's in the context of print line at least. It does magic. It is one of the few pieces of magic. Java tends to not want to do magic for you and require you to be explicit, but they decided that that was useful. And it's only converting to a string. You can't do it with anything else. Okay. Need to learn how to do it without clicking. Does this idea make sense? We have arrays. We can do things with the arrays. We could. What happens if we initialize it like this? What would get printed? Null gets printed. So I didn't initialize, right? The elements of the array. I could then do products of 0 equals P1. Does this make sense? Just a reminder, arrays start at 0. Why? Because they start at 0. Right?
Just in Java.
Sorry?
Just in Java.
In the vast majority of current programming languages, they start at 0. C1. And now every 20, 30 years ago, there was this thing about whether they should start at 0 or at 1. C, which is a programming language, decided to do it at 0 because it was faster, and at the time that mattered. And then basically C won the mindshare thing, and so every other language, not every, but the vast majority of languages that you see now came from C. So they all start at 0 because it actually makes sense. It is easier for the computer, but what other kinds of things can we do with an array, right? let's start defining stuff. Let's see. Okay, let's do double. How can we sum the prices of all the products in an array? What do we do? Right, and this is kind of one of the standard patterns is just do something with all the elements of the array. What would we do?
Product 0 dot price.
So return products of 0.price.
Plus
Oh,
1.
that would only work if you know what value they're passing you, right? And the length. How do you know how many products are there? You don't, right? Yes, you need a for loop, right? So you need to initialize. Oops. And what do I start my sum with? 0, right? And then do a for loop. And what do I do inside? Yep, add the price, right? P dot price, right? And then at the end, I return the sum. Make sense? Let me change this to a less ugly thing. Oh. Let me eliminate this stuff and then just do what do we expect to get? 3.3 or something like that, right? Close enough. Depending on what you're doing, many times, especially for something like price or something like that, you don't want to do floats because of that particular reason. But so you would use big decimal or something like that. But for now, what other things can we do with arrays?
What will be the difference with integers?
What do you mean the difference
You
with
want to do
integers?
the same with integers.
We could, right?
What's the difference?
What do you mean, what's the difference? You would never have 3.3003.
No, in the method, what will change?
Oh, the only thing that would change is double replaced by int, this particular case. Right? Price would need to be an int, too. How can I get the highest price of a product?
Again, for loop?
Sorry?
Again, for loop?
Again, a for loop, right? What am I going to start right? I need to do something like this, right? 0. It's not terrible with recursion. It's not particularly easier, I would say. What do I do inside? I need to have an if statement, right? If p dot price greater than high. Not return, because I still haven't done, right? So I need to keep this one. And then after the loop, return high. Does this make sense? Would this work? No?
We need to increment.
What do we need to increment? What would we need to increment? Sorry.
We need another integer.
Why?
Higher price.
We are keeping this, right? We are keeping the highest price. This would almost work, right? Except, let's. This would work. Except if we run a really crummy business, right? What would happen now? I return 0 because I started it here, right? So that makes it being wrong, right? I could do a couple of things. One is initialize two products of 0, right? Dot price, sorry. That's probably the easiest way, and now it would work. As long as your array is not empty.
So now we have only 2 numbers in the array, right?
We have 2 products in the array.
What if we have more?
It's no big deal. Just works, right? Because you have a for loop, so it doesn't matter how many elements you have in the array. It would work.
But if P1 equals 3.3 and then P3 equals -1 or 1.1, would it work?
Yeah.
P2 equals, yeah.
It will keep -3. It will skip.
It doesn't skip it, right? Is -3.3 bigger than 2.2? No, then it doesn't. Then it doesn't set that, right? Does this idea make sense? Now let's make it slightly more complicated. Let's return the product with the highest price. Right? I initialize here. Now high is a product, so what do I compare here? Can I compare the current product's price with high? No, because high is a product. I need to compare it with what? High dot price, right? And then equals B, and that's it. And now this would allow me to do highest priced product. Oops. And things like this, right? Does this make sense? Yes, no, maybe? Questions? No questions, it's all good. What kinds of things can I have in an array? I can have primitives, I can have objects, right? Including other arrays, right? So I could do, let me just change this to no main and start a new one. When I initialize it, right, I need to do arrays. Does this make sense? How many, what would that print? Ooh, good question. Good answers. Why would it print 6? Good possible answers.
6 elements.
6 elements. Actually, how many elements do we have? What's the type of matrix? It's an array, right? An array of what? An array of arrays, right? So how many arrays does matrix have? 2, right? It's just that, well, they are arrays themselves, right? So in this case, it would print 2. 6 was also a reasonable guess, right? Just not right. And I'm assuming that the 1 was a 2 minus 1 because of length versus zeros, right? The last element of that array is element number 1, right? But does this make sense? How many levels can I have? Can I have an array of arrays of arrays of arrays of arrays of arrays? Of course, right? The compiler will get tired way after you do, right? So you will get tired much, much earlier than the compiler. Eventually, there is a limit, but it's basically infinite, right? Does that make sense? Now, can we do things? So let's do int add all elements. How can I do this? I need some sort of for loop, right? what are the elements inside matrix? I mean, do we want to do it with indices or elements? Let's do it with elements, right? What type are the elements inside matrix? They are not integers, right? They are arrays of ints, right? Does this make sense? Now that gets me one of these guys, right? Now inside, how do I get the sum of these elements? I need another for loop, right? Now I have integers. And so now I can do int sum equals 0. Sum plus equals num, right? Does this make sense? This is a nested for loop, right? $11 and $10, yeah, 21, right? Does this make sense? If nested loops make you antsy, what do? Define functions, right? So instead of this, perfect. Sorry, my OCD is kicking in. What do? Sum plus equals what? Add all elements of row, right?
Yeah, now.
Cool. Thank you. Pair programming works. Does this make sense? What is easier for you to understand? Use whichever one makes you happier. At some point in time, you may have nested loops. You may have functions. Is this cool? So you can have arrays of objects, right? And actually, those objects may be arrays, right? Then you can have all sorts of other things. Does this idea make sense? Let me since we have time, mess up your mind again.
How about the smallest element?
What would you do? Right, let's do smallest element of what?
Array.
Which array? Like this? Or a matrix?
The metric.
Okay. What type is it? What type does it return? Integer, right? Let's do it like this. We could also define a function, right? So what do we do here? That low is keeping the lowest element we have seen, right? So what do I do inside that for loop? Check, right? Is that number lower than low, right? Num is lower than low, then what do I do? Oh, now that's the low, right? I cannot return yet, because I need to look at every element in my array. If I was doing something like contains, then I can return because I know that I'm done. But if I'm trying to find the highest or the lowest, I can't return. I have to go through every element. Right. Does this make sense? The assignment has a bunch of these kinds of relatively simple things, right? Kind of the pattern is you go through all the elements of an array and do something with it, right? And so you'll be using for loops either with an index or without, your preference, and do this kind of stuff. Now let's complicate our life with other objects. What kinds of fields could an object have? Right? For product, we did name and how can I look at this stuff? View, exit presentation mode for a second so I can look at this stuff, right? Let's go back to. I could have primitive types, right? What else can I have? I could have any other thing. String, which is an object type. I could have other object types, any object type that I want, right? Including myself, right? So I end up with recursive data structures, objects that contain other things of their own kind. Does that idea make sense? So let me define something just to make it super simple. I'm going to create a stack class. And what is a stack? It represents something like a stack of paper, right? What kinds of things can I do to a stack? For now, I'm going to keep only ints on this stack, right? What kinds of things can I do to this stack? I can add an element, and that is called pushing. I can remove an element, and that is called popping. Like if you think a stack of plates in a buffet, right? And then I can also ask what's on top. Does that idea make sense? So let me just call these things void push int n, void pop, and this is a horrible implementation of a stack, right? How could I implement a stack? What could I do? I could use an array, right? What's the possible problem? I could eventually grow bigger than my array, right? I could do horrible things, allocate another array and things like that. But an easier way is to use a linked list. So my stack is going to consist of a bunch of stack nodes where each node has an int and the reference to another stack node. And my stack has a pointer to the head, the first one. So when I push an element, what do I do? Create a stack node. Can't be in. That's it. Let me call it node. I can make it point to the old head and then make the head point to this. Pop is simpler. Head equals head.next. And top is return head.data. And as long as I'm not doing any kind of error checking or anything like that. What would this print? 2, right? The last number that I put. And then if I do pop, then print again, I would expect this to print 1, right? Isn't this cool? Let's go look at the implementation again, right? I have, this is where the magic happens, right? A stat node has 2 pieces of data, one that is an int, and then a reference to another stat node, right? And that's how the magic happens. You will see this in data structures. This is a linked list, basically, but the only other thing that we could do here is what happens when we start? What happens if we pop too many times? This will break, right? One thing that I could check is, by default, if I don't initialize an object like this, what does it get initialized to? What does an object variable get initialized to? Null, right? So here I could check if head different than null, then do this, and in here I could do similar things, right? For now, we'll see how to signal error conditions, but this would make it just not crash, right? Oops. There is just tiny. Beautiful. So now I can do this, right? And what would this print? It would now not crash and print a bunch of zeros. The stack is probably the simplest data structure you can create, other than the array. Once you have this, you have recursion, you can put all the data you want, right? Isn't this cool? Yes, no, maybe. Partially.
Stack is a data structure question, sorry.
Yes.
Stack is just a concept, and arrays and linked lists are actual.
Stack is a concept, and arrays and linked lists are implementations, ways that you could implement it.
So it doesn't exist. It's just a concept, right?
Does a linked list exist, or is it also a concept?
It exists, I think.
Why does it exist, right? Same, stack also exists. But yeah. Usually in data structures, we talk about linked lists as an implementation mechanism, and you can use it to implement stacks and queues and a bunch of other things. Then you see arrays as an implementation mechanism, and then you use them to implement stacks and queues and a bunch of other things. Does this idea make sense? Just the recursiveness of the data structure. In fact, let's add one more method, just for fun. How do I print every element in that stack?
You print the top and then top.
Well, if I do that, then I will be destroying the stack, right? How the stack, I want the stack to allow me to print every element, right, without destroying it, right? So what can I do? How could the stack print itself, right? Yes. Well, I don't have an array. I can ask it to print a stack node, right? Let's do it recursively. How do I print a stack node? What's my end condition? What's the simplest possible stack node? Null, which is not really a stack node, right? But it officially qualifies. So if n, or let's call it node, because n is numbers. if node is null, how do I print it? By not printing it, by doing nothing. Otherwise, what do I do? System.out.print line, the data, right? Yep. So node.data. And then print all with what? The next node, right? So that's node.next.
Do we need to string method for this?
Depends on what you want. We could, so we could make it it doesn't need to be static, right? So I can make it public string to string, right? Can say from the empty string, instead of printing, right? I would return what here? Return node.data plus, let's say, a comma plus to string of node.next. Right? Oh. Yeah. Right? Want this to be static. And then this, actually, this guy could have, oops, I can still do this. As system.out.println. Or I could have a string to string oh, I need what? Oh, I need to make this public. In fact, I probably want to do that override. So this would allow me to, here in main, do this. I can use actual recursion to navigate a recursive data structure. I don't have to, I can use loops and things like that, but when your data structures are recursive, recursion is nice. Does this idea make sense? The assignments are actually easier than this, but I want you guys to do more complicated stuff. Do more complicated stuff. Any questions? No? It's all good. You understand objects and arrays? Cool. Then let's stop here.